Morning, guys. Mr. O'Sullivan here. We're going to start talking about differential equations, and we're going to start with the differential equation problem from the 2018 exam. It was number 6. These are usually no-calc problems, usually come toward the end of the exam. Of course, this year there's no telling when you'll see it or anything about that. So let's go ahead and dive in. So we've got consider the differential equation dy dx is equal to 1/3 x times the quantity y minus 2 squared. In part a slope field for the given differential equation is shown below. Sketch the solution curve that passes through the point 0, 2, and sketch the solution curve that passes through the point 1, 0. Okay. And then in part B, says let y equals fx be the particular solution to the given differential equation with initial condition f at 1 equals 0. Write an equation for the line tangent to the graph of y equals f of x at x equals 1. Use your equation to approximate f at 0.7. And then in part C, find the particular solution y equals f of x to the given differential equation with the initial condition f at 1 equals 0. Okay. So let's look at, go back up, part A. So we have a slope field already drawn for us, and we're asked to sketch the solution curve that passes through the point 0, 2. Okay, so my solution curve has to pass through the point 0, 2. So the first thing I want to do is I want to find the point 0, 2 and indicate that on my graph. So that would be 0, 2 is right here. And now this solution curve I'm going to just draw is just going to go from that point. I'm going to draw left to right, following my tangent lines in my slope field. And then I'm going to do the same thing going to the left. So I really just have a horizontal line, it looks like, at y equals 2. Second one, sketch the solution curve that passes through the point 1, 0. Well, again, first thing I want to do is indicate that point 1, 0 on my graph. So that's 1, 0. This point right here. Then the same thing, I want to indicate going from that point to the right. And as I draw this, I'm going to just kind of sketch and follow along using my tangent lines as kind of a guide of how I draw my line. And then I want to do the same thing, but I want to go to the left. Go flatten out. And that's what I have. Okay, so I have my two solution curves, one that goes through the point 0, 2, and one that goes through the point 1, 0. Okay, not too bad. All right, so hopefully part A was a confidence builder. Part B says let y equals f of x be the particular solution to the given differential equation with initial condition f at 0 or f at 1 equals 0. Write an equation for the line tangent to the graph of y equals f of x at x equals 1. Use your equation to approximate f at 0.7. Okay, well, I'm going to do this one right here. And what I want to start with, first thing I'm asked to do is to write the equation for my tangent line. So I'm going to start out with point slope form of a linear equation. And then I'm going to drop in my point of tangency, which is given by my initial condition, f at 1 equals 0. That means it passes through the point 1, 0. So I'm going to substitute that. 1 is going to be my x1, 0 is going to be my y1. So I have y minus 0 equals m is x minus 1. Now I just have to find the slope. My slope is going to be given by my differential equation, dy dx. And it's going to be dy dx such that x equals 1, y equals 0. So now I'm going to just copy, so it's 1/3 x times the quantity y minus 2 squared, 1/3 x times the quantity y minus 2 squared. I'm going to substitute in 1 for my x, so I have 1/3 times 1 times, and I'm going to substitute in 0 for my y, 0 minus 2 squared. So that's going to be 1/3. 0 minus 2 is -2 squared, is going to be 4. So my answer is going to be 4/3. So that is my slope. So here's my equation. Y minus 0 is equal to 4/3 as a quantity, x minus 1. All right, that is my equation of the line tangent to the graph at x equals 1. Now, the second thing, I need to use that equation to approximate f at 0.7. Okay, so what I want to do is I'm going to rewrite this. Y minus 0 equals 4/3. And here is where I want to, I'm approximating f at 0.7. And so I'm going to substitute in 0.7 for this x right here. 0.7 minus 1. Now, all I want to do is I just want to solve for my y. Well, it's easy because it's y minus 0. So really, y is equal to 4/3 times a quantity, 0.7 minus 1. I have a numeric answer on the left side. And that is my approximation of f at 0.7. Okay. Okay. So that is the second part of part B. Now, part C, I want to find the particular solution y equals fx to the given differential equation with the initial condition f at 1 equals 0. Okay, so I'm going to do this one right here. Make sure we can see that. And my differential equation. And there's my differential equation. Okay, well, I want to make sure I'm using the correct initial condition, f at 1 equals 0. So again, my initial condition of f at 1 equals 0. And I'm asked to really find just, I'm going to rearrange my differential equation so I get an equation f of x is equal to some expression in terms of x. Okay, well, my first step, and probably the most important step in terms of the points on this problem, is I want to do the separation of variables, and I need to make sure I do that correctly. So what I'm going to do is I'm basically going to take the dx, move that to the right side, and then I'm going to take my expression quantity y minus 2 squared, and I'm going to move that to the left side of the equation. So I'm going to get 1 over quantity y minus 2 squared dy is equal to 1/3 x dx. Okay. Again, I have the y and the dy on the left side, and I have the x and the dx on the right-hand side of my equation. Okay. So again, that's my first step, my separation of variables. My second step, now I want to integrate both sides. Okay, I'm going to do the right side first, kind of build a little confidence here. So as I integrate that, I'm just going to bring my constant down, 1/3. Now I integrate x, so that's going to be x squared over 2. Okay, and so then add my constant of integration. So I can clean that up here in just a little bit, make it a little bit easier going forward. Now on the left side, what I want to do here is I want to do a rewrite to start with. So again, I'm not coming up with the antiderivative yet. I'm just rewriting my integral. And so this is going to be the integral, and I'm going to rewrite as quantity y minus 2 to the negative second dy. Okay, so I've just moved that quantity out of the denominator, moved it up, and I've just changed my exponent to a negative 2. Okay, now when I go to integrate this, and now I am finding the antiderivative of this, this is just going to be the quantity y minus 2. I'm going to add 1 to the exponent. So that's going to give me negative 2 plus 1 is negative 1. And then I'm immediately going to divide by my new exponent, negative 1. So that is the antiderivative of this left side. And that's equal to, I'm going to just clean up my right side a little bit. I'm going to write that as x squared over 6 plus c. Okay. So that is I've taken the antiderivative of both sides of my equation. Okay. Now I'm just going to recopy this. I'm doing any algebra. And now at this point, I'm going to take my initial condition, which is another way of saying when x is equal to 1, y is equal to 0. And I want to substitute that initial condition into my equation here. So I'm going to get, on the left side, 0 minus 2, the negative first, over negative 1 is equal to 1 squared over 6 plus c. Okay, so I'm going to get, this is going to be 0 minus 2 is negative 2. Negative 2 to the negative first is going to bring this negative 2 down to the denominator. And so I'm really going to have 1 over negative 1 times negative 2 is equal to 1/6 plus c. So on the left side, I'm going to have 1 over 2 is equal to 1/6 plus c. Now I want to subtract 1/6 from both sides of my equation. So c is going to be equal to 1/2 minus 1/6. Rewrite my 1/2 as 3/6 minus 1/6 equals c. So c is going to be equal to 3/6 minus 1/6, which is 2/6, which is equal to 1/3. So that is the value of my constant of integration. I'm going to take that 1/3, draw a line, and I'm going to drop in 1/3 for my constant of integration here. So that's going to be 1/3 x squared over 6 plus 1/3, and then I have y minus 2 to the negative first over negative 1. Okay, now completed that. All I have to do is just solve for y. Okay. What I'm going to do, first thing, I'm going to take care of this negative here in the denominator on the left side. I'm just going to multiply basically both sides by negative 1. So negative 1 times negative 1. So this is going to give me y minus 2 to the negative first is equal to negative x squared over 6 minus 1/3. And then my this side, in essence, what I'm going to do is I'm going to write this as 1 over y minus 2 is equal to my right side, negative x squared over 6 minus 1/3. Okay. Now, what I'm going to do is, since I have the y in the denominator here, I just want to take the reciprocal of both sides. So I'm going to flip the left side and get y minus 2 over 1, or just y minus 2. And over here, I'm just going to write this as 1 over x squared over 6 minus 1/3. And my last step is I want to add 2 to both sides. So plus 2 plus 2. I'm going to get y is equal to 1 over negative x squared over 6 minus 1/3 plus 2. Okay? And there is my particular solution, y equals fx, for that differential equation with the initial condition f at 1 is equal to 0. Okay? All right, guys. Good luck. Hope that helps. Thanks.